So now that you've learned about Young's fringes, which is evidence of light behaving as a wave, I'd like you to actually try the experiment for yourself. Your objective is to determine the distance between the two slits that are cut into this, slide. You can choose either A, B, or C by moving the laser, and I'll choose C. In order to use the laser, you'll have to move the switch to push on and then push the red button at the front of the laser, and someone will have to hold it down. The laser is kind of old. This laser is coherent light. That means that all of the waves are moving together in phase, and their wavelength is 650 nanometers. The color is red. Again, you can choose double slit A, B, or C on the slide, and your unknown in this lab is S, the distance between the slits. That's what you're going to determine. You'll see that I've got this set up on meter sticks so that you can measure this distance, L, between the slits and the screen. You're going to measure that distance, and then you're going to come over here and you're going to look at the pattern, look at the pattern that's created on the screen. And you can see in the middle there, try not to block it, you can see that I've got a central bright fringe, and then I've got the first fringe next to it. And what you're going to do is measure the difference between the centers of those. So again, you're observing this basic pattern on the screen, central fringe and then the first fringe. You'll see lots of fringes, but what you're really looking for is that distance between the central and the first. And you'll need to measure Y, the distance between the central fringe and the first fringe. And then you will have all of the data that you need to meet your objective, which again is to determine the distance between the slits S. And you're going to use the same techniques that were shown in the vodcast. Good luck.